Today we're going to be talking about how to solve real-world problems using properties of ratios, proportions, and scale factors. We're going to first take a look at a few definitions. A ratio is a comparison of two or more quantities. Ratios can be simplified, and ratios are written in three different forms: fraction form, A to B, verbal form, A to B, and colon form, A to B. A proportion is an equation that states two ratios are equal. They are written as A to B is equal to C to D, and we use cross multiplication to solve. So if I write A to B is equal to C to D, I'm going to cross multiply diagonally. A times D is equal to B times C. A scale factor is a ratio corresponding sides of a similar figure. And similar figures are polygons with the same shape but different sizes. And polygons are similar if they meet the following rules. Corresponding angles must be congruent, and corresponding sides are proportional. When something is similar, we write a similar statement, which must match corresponding angles and sides. And the symbol we use is listed below. Now we're going to take a look at a few examples of each definition. A ratio being a comparison of two or more quantities. We have an example dealing with a music store. It has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. We want to give each ratio in simplified form. So I want to compare the number of trumpets to the number of violins. 40 to 24 is my ratio. I want to write this in simplified form, meaning I want to look to see what both of these can be divided by equally, and that is 8. When I divide them both by 8, I get a simplified ratio of 5/3. When comparing flutes to clarinets, we write 51 to 39. When I divide both of these by 3, I get 17 to 13 as my simplified ratio. And lastly, we take a look at the number of trombones to the total number of instruments, which I am not given, so therefore I need to add them all together to figure out that I have 170 instruments. So I can write 16 to 170, and I would divide both of them by 2 and get 8 to 85. Taking a look at a proportion more in depth, remember that it's an equation that says two ratios, also known as fractions, are equal and can be solved by cross multiplying. So here I have an example of two triangles, smaller and larger, and I've written the proportion for each side. A is proportional to DE, BC is proportional to EF, and AC is proportional to DF, meaning that triangle ABC is proportional to triangle DEF. Now let's take a look at scale factor more in depth. Since the sides are proportional in similar triangles, the mathematical relationship between the corresponding sides is known as the scale factor. By definition, a scale factor is the ratio of the sides of the triangles. And if polygons are similar, then their perimeters are also proportional. When calculating scale factor, it is important to remember that order matters. We are going to take a look at that in 3 examples using the same picture. The first example asks us for the scale factor of triangle ABC to triangle DEF. Since order matters, and I'm starting with the smaller triangle ABC, that is going to be the side that's listed on the top. AB is 10, and DE is 20. And if I simplify, that gives me a scale factor of 1 to 2, or 1/2. When looking at the scale factor, we want to make sure that all sides are the same. So BC is 6, and EF is 12, which simplifies to 1/2 as well. And lastly, AC, which is 7, compares to DF, which is 14, which gives me a scale factor of 1/2. On the reverse side, if I wanted to look at triangle DEF first, then I would be starting with my larger sides first. So if I pick side DF, which is 14, then that means I'm going to pick its corresponding side on the smaller triangle, which is AC, and that is 7. And 14 to 7 is 2 to 1. That means that triangle DEF is twice as large as triangle ABC. If I want to compare the perimeters to verify that they are also proportional, if I add together the perimeter of DEF, 20 plus 12 plus 14, I get 46. And if I add the perimeter of triangle ABC, 10 plus 6 plus 7, I get 23. If I compare the ratio of the perimeters, I have 46 to 23, which is the same as the ratio and the scale factor that I found in part 2. If triangles are similar, then we are going to express them symbolically as triangle ABC is similar to triangle DEF using symbolic notation. This is also known as the similarity statement. Like in congruent triangles, when writing that two triangles are similar, the congruent angles in one triangle must match up with the corresponding congruent angles in the other triangle. Now we are going to take a look at some examples. I'm going to guide you through 3 of them, and then you are going to try 3 of them on your own. The first example problem says that the sides of a triangle are 5 centimeters, 7 centimeters, and 12 centimeters. What is the length of the longest side of the similar triangle whose shortest side is 20? So they are asking me to compare the longest side and the shortest side. So I'm going to start with my longest side, and I'm going to compare it to my shortest side. The longest side of my similar triangle is unknown, so we're going to call that x. The longest side of the triangle that is known is 12 centimeters. The shortest side of the unknown triangle is 20 centimeters, and the shortest side of the known triangle is 5 centimeters. We are going to cross multiply. 5x is equal to 12 times 20. 5x is equal to 240. And we're going to divide both sides by 5 and get that x is equal to 48 centimeters. That means that the longest side of the similar triangle is 48 centimeters. The next example gives us a picture. It wants us to find the length of AE. It does not tell us what it is, so we're going to use x as a placeholder. Since I know that all angles are congruent, I need to make sure that I write my proportion based off of those corresponding angles. So AE corresponds with side IR. And I want to choose another side that has a value in the smaller triangle, and the only side that is given is AF. And that corresponds with the side in the bigger triangle that goes with GR. So since AE is x and IR is 30, AF is 6 and GR is 36. We are now going to do our cross multiplication. So we have 36x is equal to 6 times 30. 36x is equal to 180. And therefore, when we divide by 36, we find out that x is 5, which means that side AE is equal to 5. Our next example gives us a picture. It is a common word problem. A surveyor made this sketch from the measurements he made along the river. What is the distance across the river from point A to point T? So since they want to know the distance across the river, that is unknown, so we're going to use that as x. We are going to set up our proportion as the amount across the river as x, and that corresponds with the side of the other triangle that matches with 40. Along the bank of the river, we have 120, which corresponds with 80. We are going to cross multiply. 80x is equal to 40 times 120. 80x is equal to 4,800. When we divide by 80, we find out that x is equal to 60 feet. At this time, please pause the video and try these examples on your own. Now that you've had time to try these examples on your own, I'm going to walk you through just so that you may check your answer. In example 4, Angela is 5 feet tall and she casts a shadow that is 7 feet long. If a flagpole next to Angela casts a shadow that is 35 feet long, how tall is the flagpole? The best thing to do here is to draw the picture. Angela is 5 feet tall and she casts a shadow, here's the sun, that is 7 feet long. That creates a triangle. The flagpole casts a shadow 35 feet long. We want to know how tall the flagpole is. So we can compare the height of Angela with the height of the flagpole and the shadow compared to the flagpole shadow. So when we cross multiply, we have 7x is equal to 175. And when we divide, we find out that the flagpole is 25 feet tall. Number 5 is a little bit different. The profits of a business are to be shared by 3 partners in a ratio of 2 to 3 to 5. That means that we have 3 people who are sharing a specific amount of money. We want to find a value that can be multiplied times all 3 ratios in order to find out how much each partner is going to receive. We are going to use that value as x. 2x plus 3x plus 5x is equal to the amount of profit. Altogether, we have 10x. When we divide by 10, we find out that that value that is going to be multiplied times each person is 17,650. We now multiply each person's ratio times the value to get how much each partner shall receive. The first partner is going to receive $35,300. The second partner is going to receive $52,950. And the third partner is going to receive $88,250. Our last example is asking you to find the value of x and then plug it back in to find the value of KL. I need to make sure that I set up my proportions accordingly. So if I compare KL, which is 3x minus 9, it is going to be compared with BC, which is 9. And then KJ, which is 28, is compared to 14 of the other triangle. When we multiply these, it is very important that you multiply the 14 times the entire expression 3x minus 9. 9 times 28. 14 times 3 is 42x. 14 times 9 is 126. And 9 times 28 is 252. We are going to add 126 to both sides to begin to isolate x. That is going to give us 378. We are going to divide by 42, which is going to give us an x value of 9. It didn't just ask for x, it also asked for KL. That means we need to find KL. By plugging in the value of x into 3x minus 9. And we find out that KL is equal to 18.